Hey Ryan, obviously this is inspired by your transistor-based full adder, but as you can see, I'm not using any transistors. Instead, I'm using an ESP32 right here. Because of that, there's some things that I can do that you cannot do. For instance, instead of having LEDs on the inputs to represent the values, I actually use the same LED out here. So whatever one changes, so if this changes, it reflects there. So that's a 1, that's a 3. And you could change things around, but if you make a change onto this one, it will actually reflect this one. So let's put a 4 here, and there's a 4 right there. So I thought that was pretty cool. And of course, once you set your values, let's just say 1 plus 1, so they're both 1 1, and then when you're ready to add, you press this button and we have a 2. Let's make this a 3. 3 plus 1 is a 4, and there's a 4. And I'm sure you want to see an overflow. So that's a 15. And once I do that, of course, we cannot add any more. So let me see what happens when you overflow. It errors. It blinks error. So, but if you decrease 1 here, so we should be able to still add 1 to it. And that works just fine. So, I mean, this is completely useless. And the code is even more interesting because I actually implemented the gates. So this should look very familiar. It's a 4-bit full adder, of course. Up here, you can see just a 1-bit adder, adding these 2 bits together for the result here. And if there's a carry, that's chained down the line for 4 bits. I actually implemented this in MicroPython. And this is that circuit. So you pass in 3 things, the A, the B, and the C. And the output is going to be the out and the carry. Since the output of this XOR gate is being used by this input and that output, I put a temporary variable there, so I don't have to do it twice. So that T1 is this point right here. And then the output is going to be another XOR of the T1, the output of this guy, with the carry right there. And then the carry output is going to be this AND gates and the OR right here. So there's the AND gates and then there's the OR. And I return the result, the out and the carry. And to do the 4-bit adder, I just call it 4 times, and I accumulate the sum into here, and then the carry will keep on carrying as it goes through each loop. It will be carry for the next time in the loop, and then I return the last carry in here. So I thought that was pretty cool. So this actually is emulating this whole thing. The rest of the code is just simply to deal with all the buttons and all the LEDs. So yeah, it's completely pointless, but I sure had a lot of fun. Thanks, Ryan.